Now let's discuss how to find the complementary function of the solution. Complementary function for the differential equation which is given like this. X is a constant or a function of x alone. So we want to find the complementary function. Your solution, complete solution is written as Ca plus Pi. So complementary function part of the solution is having two parts, complementary function and particular integral. So complementary function is the solution of the differential equation f dy equal to 0. Now what we do is we find the roots of, first of all we replace d with m, or what you can do is you can just put y equal to e to the power mx, right? Just put y equals to e to the power mx. So your dy is going to be m e to the power mx, d square y is going to be m square e to the power mx. So this equation, which is nothing but dny an minus 1 dn minus y and this will go till and a and y equal to 0. So if I put y equal to emx, e to the power mx, it comes as mn n minus 2 plus y equal to 0. This is nothing but you will have, this is a polynomial in M. This is nothing but polynomial in M equated to 0. This is called auxiliary equation, or simply AE. This is called auxiliary equation. Now we find root of this equation, roots of this equation. So the roots can be, say, simple roots like 2, 3, 4, 5 like this. It can be complex root of the form alpha plus I beta, or it can be in the form of surd, right? It can be in the form of surd, like alpha plus minus root beta. So there can be three cases. One, the auxiliary equation where I give you simple roots, right? In the second case, it can be roots of the form alpha plus minus I beta, or it can be a root of the form alpha plus minus root beta. It will be in the form of surds, you call it surds, or you call it complex roots. So let's discuss one by one these three cases, when the roots are simple roots, when the roots are complex roots, and when the roots are surds, right? What happens when you have surd? See, when you have simple roots, case 1, when the roots are simple, right? In that case, the complementary function will be given by, suppose the roots are m1, m2, see, we can write, suppose the roots of auxiliary equations are m1, m2, mn, right? So if these are the roots, in that case the complementary function can be written as c1 m1x plus mnx, right? Now if suppose m1 is equal to m2, in that case c1 will be written as m1x plus mnx. And if suppose these are equal, first r roots are equal, in that case your CF becomes C1 plus C2x plus CR XR minus 1 e to the power m1x CR plus 1 mr plus 1x and so on, c to the power mnx. Alright, like I can take the example. Suppose we are given an equation. This is differential equation given to you. Let's factorize this. This will be d cube minus, see, d equals to 1 will be the factor, right? So will be the root. So d cube minus d square plus d square minus d minus 2d plus 2 y equal to 0. All this will be d minus 1 y equal to 0, or d minus 1, or this is d minus 1. So d equals to 1 is, say, the roots are repeated over here, right? So I can say complementary function is c1 plus c2 ex plus c3 e to the power minus 2x, because d equal to 1 root is repeated over here. We have c1 plus c2, sorry, c1 plus c2x, I'm sorry, it will be c1 plus c2 x e to the power x, and this will be c3 e to the power minus 2x. So this is a complementary function. So we can find the roots, we can find the complementary function, right? We can find the complementary function like this. Now if suppose, let's move to case 2. If suppose the roots of auxiliary equations are of this form, right? In that case, the complementary function corresponding to these roots are going to be c1 alpha plus I beta x and c2 alpha minus I beta x. So this can be written as, I can write this as e to the power alpha x c1 I beta x right. So it says e to the power alpha x and c1. If I open this, see, e to the power I theta is cos theta plus I sin theta. So this can be written as, if I open this, e to the power I beta x as cos beta x plus I sin beta x, and I say cos beta x minus I sin beta x, then this can be written as c1 dash, or you can simply write c1 plus c2 cos beta x and sin beta x. This is e to the power alpha x c1 dash and c2 dash sin beta x, right? So this is the roots. This is all you can write the roots. If suppose these roots are also repeated, suppose the roots are, these roots are repeated twice, these roots are also repeated, in that case your complementary function is going to be e to the power alpha x c1 plus c2x cos beta x, and this will be c3 plus c4x sin beta x. This is going to be a complementary function. This is going to be the complementary function. If suppose they are repeated r times, if they are repeated r times, like you have c1 r and you have d minus, you have r times, right? Alpha plus I beta is repeated r times, alpha minus beta I beta is also repeated r times. Then in that case, this will be CR XR minus 1 cos beta x and CR, sorry, this will be C1 dash, C2 dash, this constant will be different. Sin beta x, this is going to be the complementary function. Now suppose the roots are of the form alpha plus minus, say, root beta. In that case, your complementary function is going to be c1 e to the power alpha plus root beta x plus c2 alpha minus root beta x, right? Alpha minus root beta x, right? So this is going to be e to the power alpha x and c1 e to the power root beta x and c2 minus e to the power root beta x, right? I can write like this. Alright, I can write this thing like this. Now you know cos x as e to the power and sin x as upon 2, right? So from here I can also say e to the power x is sin beta x plus cos x, right? And e to the power minus x as cos x minus sin x. So this can be simply written as c1 cos hyperbolic function beta x plus sin beta x and c2 cos beta x minus sin beta x. So it's nothing but e to the power alpha x c1 plus c2 and says c1 minus c2 root beta x. So I can write this as c to the power alpha x c1 dash plus c2 dash sin. This is the complementary function, right? This is the complementary function, right?